Okay. All right. So yeah, basically gonna go over starting from the Wines API and make a few modifications, and then we'll get it deployed on AWS. So for today, I'll try to make this relatively snappy, and then you guys can work on this for a few more hours, and then this afternoon I will release the the last assessment effectively. So it'll be the Django assessment. So it shouldn't be anything surprising, um, you know, nothing that you haven't seen before. All right. So I'm going to start by checking out this wine API. So I'll pull that down. Actually, let's see. And actually, I think I just changed the README. So this is actually wrong. We want the start one. I'm just going to modify this real quick. Okay. Cool. So now I'm going to check out. So git branch dash A, and I want compose v2 start. So git check out compose v2 start, and I'll open this in code. Okay, so what this has now is basically only the database container. So the idea with this is that you would, if you wanted to actually run this, you would run Docker compose up. That would start a database container, which is mapped to port 5454. And then you would install all of the requirements, create a virtual environment, install the requirements, and then you would run the Django application locally. But we're going to wrap the Django application up in a container, and then we'll make another modification later. So first, we're going to add a Docker file, and this will be for the Django application. So this is, excuse me, going to start from a base image, and then it's going to copy over requirements.txt and install them, and then copy over basically everything else. This could be more specific, but so we just need to copy over the application here. And then we're going to use, instead of running this in the local development server, we're going to use a real application server, in this case, green unicorn or Gunicorn. And we're also going to run it on port 8000, but this is a little bit more sophisticated way of running the application server. All right, and then I'm going to update the Docker compose file to now include this. And here we go. So now we have this, in addition to the database, we now have this API container, and it's still going to be mapped to port 8000. So that's stuff we've seen before. And then we're also going to need to add this new dependency to the requirements.txt. So I'll throw that in there. And then we'll need to also update our database configuration, because we're not running the application locally anymore. We're going to run it inside of a container. So the way it connects will be slightly different. So we'll go into the settings.py, And instead of localhost, right, because we're not running it locally anymore, we're going to run it in the container. So these two things are going to change. So this will be the default Postgres port, which your Postgres container will be listening on. And then we're going to pass it the name of the container that we gave it right here. And when Docker Compose spins this up, it will spin up both of these containers, and it will automatically put them on its own network. So Docker Compose will have an internal network that these containers are running on, and it will actually have its own basically DNS resolution. So when it runs these two containers, it will run them on a network, and it will assign them both an IP address. And that IP address will be assigned basically dynamically by Docker Compose. So you don't have to go in and figure out, what's the IP address of the Postgres container. You can just use the name, and Docker will automatically resolve that to whatever IP address it is assigned. So you can just refer to that as DB, and this would be like, www.example.com or whatever. So you don't have to know or care what the IP address of example.com is. You just use the convenient name. Okay. And once those changes are made, we should be able to run Docker Compose up. If anyone has any questions while this is spinning up, feel free. Okay, and then once that spins up, we're going to go ahead and run the migrations. So we'll exec into the API container, which should be named something like this. We can double check the name, but we'll exec into this container, and then we're just going to execute the migrations. Once we run those migrations, then in the database container, all of those tables that we need, that we've defined in the application and that Django has defined by default, will get created. And once that happens, we should be able to use Postman or something. It looks like I have this twice here. I was updating this last night, so I missed a couple things. All right, so I'm going to do Docker PS, make sure everything is running. So both these containers are running now. So that's what I'm expecting to happen. And I can access the API through port 8000 on my local machine. And then I don't really need to directly access this now, but as you're developing, it's nice to do this, because if something goes wrong, then you can directly get into the Postgres container. But when the application is actually deployed, you don't want anything from the outside directly talking to the database. You only want the API to do that. So we'll eventually remove this. But for now, as you're developing, you can leave that there. All right. So I'm gonna run this one. Okay. So all the migrations are now applied. So the application should be ready to go. I'm just gonna modify this real quick. All right, so this application should be working. So we should be able to now go into Postman and test it to make sure that everything's working. So here, this one. So I'll go to localhost, HTTP localhost, blah, blah, and I should be able to go to wines, and it should tell me that I can't access the resource. Okay, so it's working. The request is going through. There's no errors, but it's sending me a message telling me that I need to be authenticated. So we'll have to go through the authentication process to get a token. So instead of wines, it'll be, forget what it is, but let's double check right here. You can double check in the application code. So we go to the top level urls.py, and it looks like it's accounts. So I'm going to go to /accounts /sign up. And I'm just going to send, that's going to be a post request. So I can send that. And it will tell me that I need to supply a username and a password. So now I'm going to go to the body, and I'm going to send some JSON in the body. First thing is going to be username, whatever the username is, and then password. Okay, and now if I send this now, I get a response. So this tells me that the user is created. I could now, if I, I can now directly go in and check that user exists, but I'm going to assume that that just worked. So now instead of sign up, I'm going to go to get token, which is like logging in. And I'm also going to send these same credentials so I can leave the body there. And I should get a token back. So there's the token. And once I have that token, now I can go back to my original request, and I need to include this token in the authorization header. So I'm going to add a header, authorization, and the format that this application is expecting is the word token, space, and then the actual token. And I'll send this. And I don't want to go to wines 1. I just want to go to wines, because no wines actually exist right now. So you'll get an error if you try to access a resource that doesn't exist. But you can go to wines to get the list of all of them, which is empty. But we know that it's working. So any questions about that? Okay. All right. So we've basically seen that before. So what we're going to do now is we're going to update the architecture of our application a little bit. And what we're going to do is we're going to insert another HTTP server in front of our API. So on the Django side, currently we're running this G-Unicorn application server, which is handling requests and then executing, different views and making calls to the database and then returning a response, which is fine. But what we're going to do now is put that behind an Nginx server. And the Nginx server eventually will be the entry point for any client. So any client that wants to use your application is going to have to go through this Nginx server. And the Nginx server is going to look at that initial request, and it's either going eventually to serve up your React application, so your JavaScript, HTML, etc., or it's going to hand off the request to this Python application server, so it can do its thing. Right now, we don't have the React code, but we'll add that eventually later. All right, so we're going to add basically a third service or a third container to our Docker Compose file. So we're going to create a new folder called web server, and we're going to create a new Docker file that's going to describe that container. And Docker file. Okay. And then we're going to modify some configuration. So we'll just, I'll just include this real quick. So this is called default.conf. And if you look at the Docker file, it's expecting a file in web server called default.conf. And it's going to copy that over inside the container to this etc nginx conf.d/default.conf. And this is just something that you would have to know from reading the nginx docs. But what this configuration is going to do basically is it's going to say, hey, I want this HTTP server to listen on port 80, which is the default HTTP port. And then what we're also going to do is, for the time being, any request that comes in that has /API is going to get proxied. It's going to get rerouted to the application server. So this right here, this API is actually the IP address of this container. So we now have the nginx container, and any request that it gets from a client is going to come into this nginx container. The nginx container is going to be listening on port 80. So we'll go to, example.com / example.com, port 80, which is implicit. And then it's going to check the URL and say, hey, did you go to /API? If so, then we're going to pass this off here, and we're actually going to forward the request to the application server. Eventually, when we get to React and you have your front end stuff in here, we'll also add another route for that. But that's all that's happening right now. Okay. So we're going to update the Docker Compose now, because we need to describe 3 services. So we have the API, and now you don't need to do any port mapping because the outside world is not going to talk to the API container directly anymore. It's also not going to talk to the database container anymore. Any request is only going to, is only going to talk to the nginx container. So the nginx container is going to be listening on port 80. It's going to take in requests, and then it's going to forward them to the API container, which will then also talk to the database container. Are there any questions about that so far? Okay. All right, and we're just going to update a couple things. So we're going to have to update the allowed hosts in settings.py. we could be specific. So you could include, so when we eventually deploy this, you could include the IP address of the EC2 instance that you're using, but this is fine for now. So allowed host, we just have to make sure that that is there. And then we're also going to need to modify these URL patterns, because now now the Nginx server is expecting things to start with API that need to get routed to the API. So we'll go ahead and update that there. Go to the top level URLs. This is the top level. And instead of just wines or accounts, it's now going to be API/wines accounts. Okay. All right, so I'm going to spin this down. So Docker compose down -v. And I'm going to do Docker compose up -build -d, and we'll see if this works. So if I do Docker PS, I should expect to see 3 containers up. Okay, I have the API container, I have the Nginx container, and then I have the Postgres container. And the Nginx container is the only one with external port mapping. Okay, so once I have that, I should now be able to do the same exact process that I went through here, except the URL is going to be a little different. So instead of localhost 8,000 wines, it's going to be localhost port 80, which is implicit here, /API/wines. And I will remove that. Okay, and we get that same initial error we saw before. So everything's working, the request is going through. It's telling me that I need to be authorized. So I'm now going to go here. I'll do the same thing. So again, this is not going to be, we're going to have, all our requests are going to have to go through the Nginx server. So /API/accounts. And then this will be sign in, sign up. I'm getting an error. Let's see. So what's the problem? So any guesses as to why this error is occurring?
Did you not do the migrations, maybe?
Exactly, yeah. So it's telling me that so what is a relation?
I mean, it's basically like a SQL table or the
Yeah,
models.
exactly. Yeah, so a relation is another word for a table. So it's telling me that a relation auth user does not exist. So it's a table called auth user and it doesn't exist. So the API, when I'm trying to sign up, so it's gonna take that request, it's gonna go through the Nginx container, see that, oh, it starts with API. I'm gonna pass that off to the Django application server. It's going to look at that. It's going to say, oh, you want to go to /accounts. So it's going to call the appropriate view. And then that view is going to try and contact the database and say, hey, I've got a new user here. I want to submit the username and password. And then the database says, hey, that table doesn't exist. So that's that's the chain of events that is getting us this error. And the solution is to just run the migrations. So I can actually do that by execing into the container and running that. Okay, so now if I try to make this request, it works. And then I'll go to get token. I can't remember the names of these endpoints. Okay, I have the actual token, and now I can go back here. I'll add this authorization header and supply that token, and I get my wines, which we don't have any. But so the same exact process should work exactly the same way, except that we've changed the architecture a little bit. And one perk of this architecture is that we don't have to worry about CORS errors anymore, because everything is coming through that one Nginx server. So everything's coming from the same IP address and port. Okay, any questions so far? Okay, so now we're going to deploy this. All right, so before I do that, I'm going, since we're still, eventually what we're gonna do is we're gonna end up pushing all of these containers to your Docker Hub account. So you're not gonna have to need to clone down your repo on the EC2 instance. But for now, that's what we're doing. So I need to create, I'm gonna create a public repo so I don't have to worry about GitHub credentials. So to do that, I'm just going to do rm-rf.git. And I'm going to create a new repo. So git init, git add. And then I'm going to go to GitHub. To my personal GitHub account, I'm going to create a new repo. And I will call it drf example. I don't know if that's good. And then create the repository. Okay, and I'll copy this stuff over. It's fine. And then git push origin master. Okay, so I have this code available on a public repository in my account. So once I have that, now I'm going to go and I'm going to create an EC2 instance. So I'm going to go EC2. All right, I'm going to launch an instance. And I can call this whatever I want. I'll use the Amazon Linux image. Yeah, I think, yeah, I have an older Mac, so that's fine. And then micro, and then key pair login. I'll just reuse one of these, sshkey.pem. If you don't have one, yeah, if you don't have one, then you can create one. I just have an old one lying around for examples, so that's fine. I'll just reuse it. And then I'm going to allow SSH traffic. I can just do it from my IP address. And I'm also going to allow HTTP traffic. So this is just going to allow requests to come in on port 80, which is what we're expecting to have. Okay, that should be good, and I will launch the instance. Okay, I'll go to connect to instance. Okay, I'm gonna copy this, and I'm also gonna go, I'll just temporarily drag this in here. And now I should be able to execute this if the instance has been created by now, which it might be. Yeah, I'll have to wait for a second. Let me try that again. Okay, yes. All right, so now I am inside of this container. So I'm gonna install, I need to install, in our case, Git and Docker and Docker Compose. So I'm gonna copy this and paste it in there. Okay, so I should have everything I need installed, and then I'm gonna clone, I'll clone the repo down. So that is right here. So on my EC2 instance, git clone. Okay, and I can see, so I'll cd into drf example, and then I should be able to run Docker Compose up. So Docker Compose up -d. I think I have to use the Docker dash compose. So there's a history there between Docker dash compose and Docker compose, but they both do the same thing. So okay, and then once this is going, I'm gonna check to make sure that all 3 containers are up and running. Basically, that there's no additional problems. If it runs locally, it should also run here, but we're still gonna double check that. Yeah, and then after that, we'll remember to run the migrations. So eventually, you'll probably want to put all of these steps in a script to make your life a little easier. And things are going to get a little more complicated down the road with environment variables and stuff. But for now, let's make sure that this is working. So Docker PS should have 3 containers, 1, 2, 3. This container is going to map to port 80, which our EC2 instance has exposed. So we, as clients from the outside, should be able to make an HTTP request to the IP address of the EC2 instance on port 80, and then that will get forwarded to the Nginx container, which will be listening on port 80, and then that request can come in, and then it'll get handed off to the Django application server. Okay, so now I got to run migrations. So let me just copy that command. Oh. So this might not work. Notice that the name of the image by default will be based on the root directory. So this command won't exactly work. So we're going to have to modify this. So DRF example API. Oops. So here's the name. Sorry. Here's the actual name of the container right there. So DRF example API -1. Okay, so the migration ran successfully. So this should be working now. So I should be able from the outside to get the IP address. So I'll go to get the IP address of this container, which is right here. So let's copy that. And then I'm going to go to Postman and I'm going to go through the same process. So we're going to start with the IP address. So HTTP : / and then /API/wines. And suddenly we have an invalid token. So let me remove the authorization header. And here we're going to start the exact same process, except now we're just doing it somewhere else. So let's go through the same process again to make sure everything works. So we're going to create an account. So sign up. I'll pass in a username and password. That's interesting. Let's see. Okay. I'm not sure how that could happen. Maybe I accidentally did something. It's very interesting. Okay, but in either case, we have a user, so we've just created a user, and now I'm going to get the token. Okay, so I have this token. Oh, it's localhost. You guys gotta keep me honest here. Okay, so I'm going to go to this endpoint /API account signup. So there we go. There's the username and password. And now I can actually get the token. So I'm going to grab the token, and then I should be able to supply that in the authorization header. Going to this EC2 instance and send that, and then I get the result. So that's the whole thing. You're just kind of, basically everything should always work exactly the same way. But the underlying stuff can change, but the basic process is the same. So whether you're running it locally or whether whether it's fully containerized or partially containerized locally, whether it's running on an EC2 instance, if it's running on 10 EC2 instances, if it's running on some Azure compute instance, it shouldn't matter. As long as your application works, you package it up using Docker Compose, and then you should just be able to throw it on any computer anywhere that has Docker installed on it. All right. Any questions about that?
So I was expecting to have to do the security group thing again. Is that we don't need to do that because it's on port 80 running through the Nginx? Is that correct?
Yes, exactly. So when you're creating the EC2 instance initially, and you say allow HTTP traffic, what you're doing implicitly is creating a security group that says allow traffic on port 80. So we can actually look at that. Let's see. We can look at this security group and you can see that it's allowing. So what is port 22 for?
SSH.
Yeah. So the SSH uses port 22 and then HTTP, unencrypted HTTP by default will use port 80. So when we created the instance, we said, hey, allow SSH traffic and allow HTTP traffic. Since everything is going through this single Nginx container now, that's the only thing that the outside world needs. So we don't have to add another security group for port 8000 so you can hit the API or directly. Does that answer your question?
Yeah, it does. Thanks.
Anything else? Okay. So for today, ideally, you guys will be more or less done with the actual application, and then you can deploy it. If that's not the case, and it's going to take more than a couple hours to finish up, let me know, and I can jump in and give you a hand. But the goal for today is to get your application, your car's API finished and Docker composified and then deployed on EC2. And then this afternoon, I will release the assessment, which will be due on Monday. Okay.